Hi all, in this video we're gonna fine tune QuenB 1.5 billion model chat. So basically it's a lightweight open source model from Alibaba. It's basically designed for real world tasks such as financial sentiment classification and etc. So what we're gonna do in this collab is we're gonna fine tune it, and then we're gonna do sentiment classification and gonna use LoRa and Unsloth for the model training and for model handling. So fine tuning is when you take a pre-trained LLM and make it better at a specific task, like understanding the financial emotions. And coming to sentiment classification simply means predicting whether a sentiment is positive, negative, or neutral. And we're going to use tools like Unsloth and LoRa, which allows us to do this fast, cheap, and using very little GPU power. Basically, the GPU power depends on the dataset size. So, all right. First, we're gonna install the necessary libraries. We're gonna install Unsloth with SanDisk, which is used to load large models in 4-bit precision. And we're gonna use TRLs. It's a Hugging Face library for supervised fine tuning. And we're gonna use standard datasets which are publicly available. And then we're gonna authenticate Hugging Face and WANDB. So we want to track experiments and save models. So basically, Hugging Face saves models to cloud easily, and weights and biases. You can track your training loss, accuracy, and performance over the time using WANDB. So next, we're gonna load the Qwen 1.5B model. So Qwen models are optimized for conversational tasks in general. Here we're gonna set max sequence as 2048 tokens, which allows for long input and output. So here we are using 4-bit loading basically because it saves over 50% memory without major quality loss. So always set pad token to avoid tokenizer warnings. And then now we're going to load our real world dataset, which is Financial Fliss Bank. So the concept of the database, basically the database has the financial data, which is of the form short financial news sentences. So we're going to classify each sentence as a label, whereas 0 means negative, 1 means neutral, and 2 means positive, respectively. And then we're going to do class distribution. Basically, it's important because if data is imbalanced, your model could become biased. So class distribution plays a key role to get the overview of the data and the results properly. And now we reframe the data into instruction input response format, like how chat models are trained. So we teach the model to understand structured tasks, therefore instruction and then input and then response. And now we tokenize the formatted text. So input IDs are fed to the model, and labels are what model should predict. We're going to enable LoRa training and gradient checkpointing. We're going to use LoRa because it fine tunes only small matrices inside the model, therefore 95% few parameters to train, and it's basically faster and cheaper. And now we define how we want to train. So we're going to set batches is 4 and accumulate 2 batches before backpropagation and train for 3 full epochs. And now let's train our model. So we're gonna do casual language modeling, not masked LM, meaning the model predicts the next token without hiding the words. After training, just save your model to LoRa adapters so that you can use whenever required and can be reapplied to other Qwen models easily. So now let's run few inference tests. So these are the results. That's it.